Hello. I'd like to present a presentation entitled Towards a Decentralized Web and E-Governance of the Future. It's part of the GLASS project, and which is co-funded within the Horizon 2020 programme by the EU. It involves a number of universities and companies working together to try and build the next generation of citizen services. So what's the problem? The internet that we have now really is a legacy internet. The protocols, IP, TCP, HTTP, all of those things were really built around the start of the internet and have stayed much the same. The databases that we use are roughly the same. We hardly ever design systems that are secured by design. We hardly ever think of privacy as a core element of what we try to build. And we typically don't integrate trust. Trust is something that we hope we can build up in the future when our products are released, and there's no real scaling of much on the internet. Everything becomes centralized. Government data is held in silos. Facebook owns their own data. So we need to change that world. And we need to start to build systems that are truly built around the citizen and the citizen's rights. We need to build a new economy, one that is digitally focused in everything that it does, that doesn't have the legacy of folders. Folders come from a time when we had paper folders and we put them in filing cabinets. And forms comes from a time when we had paper forms and we filled them in with pen and paper. And signatures comes from a time when we had wet signatures. These are all old concepts, and we need to move away from scaling this old world and to build a new world. And one thing we've done with the internet, and the internet was meant to be decentralized, and there was meant to be multiple routes that you could get to a destination. And also the content within it was meant to be centralized too. There was to be one place that you could store something, and then you could access it wherever you wanted and bring things together. But unfortunately we've centralized. And we're centralized around these things called URLs or URIs. And that is a centralized system. We have a single point of failure. If we want to access Facebook, if the Facebook service goes down, then no one can access the service. So we need to look at different models where we can distribute content across the world, and where there is possibly few chances to censor that information. And we need to rebuild our systems. Many of the systems, especially for things like healthcare, have been built around the stakeholders, the employees inside the healthcare infrastructure, and tend to be siloed. This leads to centralized approaches and non-integrated. The healthcare tends to be ad hoc, clinician focus, reactive, and where we have clinician control of healthcare records. What we need to move towards is an information age, and where we have distributed patient care is holistic, where we look at every single individual citizen and build healthcare plans for them. It is patient focused, preemptive, where we can actually determine when someone might have a problem before it even shows. But we need to preserve the rights of privacy for our citizens and not spy on them, and for the citizen to have much more control of their own health care. But if we scale this to lots of government services, then we could design our e-governance services to have the citizen right at the core. And this was a presentation on the BBC, and it was from the Master of the Rolls, who outlined that much of what happens in law could be enacted with smart contracts. And in 20 years' time, what would a house sale look like? Well, it could be done and recorded on the blockchain, and where there is a smart contract which will run through the things that are done through our existing legal systems. So we can see if we could start to transform our existing world, we could integrate much more trust into it. And a core part of this must become smart contracts. And with a smart contract, we can enact something either within a permissioned area, where we can run within an infrastructure, where the scope of the smart contract will only run for the entities involved inside that infrastructure. Or we can run permissionless, and these would run on a global scale on a public ledger. So smart contracts can enact many of the things that we interact with at the current time. They could trace things easier and enact a contract which was fair on all sides of the contract. And then we need to really move away from the concept of our wet signatures. Much of the infrastructure we've created in the internet at the present is really still based on wet signatures and the concept of adding a manual signature. What we need to do is to move much more towards providing better focuses for identity. And one of the best things that can identify someone is their private key. In public key encryption, which has been around since the late 1970s, we create a key pair. We have a private key and a public key, and we sign for a message or a transaction with our private key. We can keep that secret, and everyone can see our public key. In this way, only the entity which owns the private key should have that one. So in the future, we need much more trust built into our transactions, and where the entities involved can actually properly digitally sign things. Okay, so let's have a little bit of context before we look at how we could build our e-governance system of the future. So the EU wants to integrate over 447 million citizens, over 27 countries, and where there are at least 24 different languages. So how can it make sure that each of these countries can integrate together and harmonise their governance services? And that is the challenge of this project. And what we've came up with is an architecture which starts to build an ecosystem for the future. It probably will take years or even decades to build this infrastructure, but we need to move away from our siloed systems. So the GLASS infrastructure aims to enable organisations to join a secure and trustable distributed network to demonstrate the capacity of a modernised e-governance model. Within it, and at the heart, is a citizen wallet. It is this wallet which will hold credentials for the citizen, so that rather than continuing to request them for proof of identity, for birth certificates and so on, they will be held within the citizen wallet. And then there will be an ecosystem of distributed applications which can run smart contracts to be able to enact transactions on the citizen's behalf. And then at the back end, we have the possibility of use what's called the interplanetary file system. And it's this system which can distribute the web rather than using a centralized approach. It is this system which would allow different versions of a document to exist, and then for a user to point to the right version of it. And it's really this system which will start to build a truly citizen-focused infrastructure for e-governance services. So here's a use case. So the use case is that Alice is in Greece and applies for a job in Portugal and gets it. But unfortunately, there are many barriers in the way of Alice moving from Greece to Portugal. On the one end, she needs an ID card and social security number, a bank account, proof of identity, and so on. And the entities involved might involve the Ministry of Justice in Portugal and the Ministry of Digital Governance inside Greece. And for this, she needs stamped and authenticated documentation to move from one country to the next to fill her job. So she needs validated ID, a birth certificate, national certification, and so on. But why can't she just do these things once? And every single time that she's applying for a job, or wherever this type of identity is required for another service, doesn't she store the credential within her wallet? And then she can just reveal that whenever a service requires it. So Alice uses her wallet, and the first time she requests her identity details, she stores it in the wallet. And then whenever there is another service which requests that information, she can then take it from her wallet rather than having to go through the whole process of asking and proving her identity. A little bit like digital certificates, where we have trust in a digital certificate for a certain amount of time. We don't have to continue to prove the identity of the entity. We have a trust which will allow the document, the certificate, to be valid for a certain amount of time. So a wallet could contain birth certificates, details, ID documents, passport details, academic qualifications, and so on. And all of these could be run through smart contracts run within distributed applications. And it's these distributed applications which can implement the processes that are involved in a trustworthy way, but also to track all accesses to the information. So let's first look at what's called the interplanetary file system. And this is an infrastructure which replaces our centralized web. So as I said, we have a service, and the service is run off a server, and we access it through a URL. If that service goes down, then we often can't actually access it. So the interplanetary file system does it differently. It takes content and then gets a unique identifier for that content. So we have a content ID, and then we just refer to that content ID and then it's found. So just like saying, I'm looking for a document called fred.doc and asking for it, then the internet can actually provide us with the document back again. But the amazingness of IPFS is that I can have Fred version 1, Fred version 2, Fred version 3, and so on. And the internet will keep track through what's called a DAG, or a Merkle acyclic graph. And it's a method that something like GitHub uses to be able to keep track of different versions of a document. And basically what happens is that we take a document and then we take a hash of that document. And that hash will be unique. If it's a big enough hash, 256 bits, then every document can have a unique hash. And then if we have larger documents, we can split them up into lots of other fragments. Then each of the fragments can have their own ID. Then we can bind all of these IDs into a single entity, which will be the content identifier. And then what we can do is that we can distribute each of those little fragments across the internet. So we might store it in 100 different places. And in that way, we don't have any firewall problems. We can access the files that are probably close to us. So if there's a server somewhere which is hosting these little fragments, then rather than going to a far off server to be able to access it, we could take it from a local service, or we could take it from multiple services. So a bit like BitTorrent. BitTorrent will split a file into little fragments, and then we can seed those fragments from lots of different places. We can do the same with the interplanetary file system. And a blockchain keeps track of the hashes and how they are mapped into objects. So this is an example here. So we might have a file, and the file will have lots of fragments. Each one of these fragments will have a unique CID, or content ID, and then we'll map to an overall content ID. So when we ask for a document, we can ask the internet for this hash value here, which will map to our file ID. In this case, we have a directory. So we can actually map our directory structures and so on into an object. And within inside here, there are 3 files. So the folder has its own CID, and within there we have 3 files, each which has their own CID. But obviously that CID could be mapped into another folder, so that we only have to keep one version of the CID for this version of the file. And then we can have fragments of the file, and the fragments of these files will be split up and can be stored, so that when we access them, access the CID, then we access the data within inside them. So this is an example here. So there are a number of file infrastructures which are already seeded onto IPFS globally, and then these are then seeded across the internet. So in this case, here's a file here. There is the global CID for the file here, and then this file is a directory object of 57 gig, and then contains this these files here, which are again identified with a CID. When we want to access the files. So in this case, we have some files here. We have a file here. If we want to take the CID, then when we're accessing it on the internet, then we can access it with the CID value. So in this case, we'll have a look at this README file. So we'll go here and we'll access that one, and we can see here, rather than accessing it through HTTPS and so on, we can access the CID directly from a browser. So the way that this is set up, we can see here that I can contact 125 different peers which are running these IPFS services. That's increasing here. So what happens is that whenever I require a CID, then it will call out onto the network to be able to find the content. So it could be multiple CIDs, and then hopefully the local server will have those content fragments and return them. If not, it will contact other peers across the world until it finds them, and then eventually it will exchange those fragments so that they can be provided to the requester. And obviously once they're provided, they could be cached, and the next time they're accessed locally, then they can be produced without actually going out onto the rest of the internet. So we can see that we can start to distribute our files and our content across the world. And in this way, it does not respect boundaries or firewalls and so on. And it's very difficult to suppress the spread of information. Okay, so IPFS provides an interesting infrastructure to be able to distribute content across the web. So let's look at some related work and see how researchers are using IPFS and blockchain, smart contracts and so on to build more trustworthy systems. So this is an interesting paper here, and it proposed a way of sharing secure data through IPFS and blockchain. So basically the way that IPFS works is that we put the file into IPFS, it then returns back hash values that are required, and then those hash values are then seeded across the internet. But this method here then encrypts, takes the file and then splits it up into a number of shares. And each of those shares are then encrypted. So we want to rebuild the file, we run it from a smart contract. And the smart contract is able to take the shares, the encrypted shares of the file, and then take a number of those shares and rebuild it back into the original document. If anyone was to look at each of the little fragments which exist within IPFS, they would not be able to decrypt these. And it's only the smart contract which runs that controls access to the files that can actually rebuild the file as it was in its unencrypted form. The one thing about IPFS, and one of its weaknesses, is that once the fragments are seeded with the CIDs, it is extremely difficult to delete them. And there isn't a current mechanism to be able to make sure that they're deleted. So one way to make sure that the files cannot be accessed in the original form is to encrypt them and get a smart contract to be able to rebuild them with the right encryption key. So the paper then extends into using off-chain and on-chain methods to be able to share files. With this, the off-chain part is not stored on the global blockchain, but is stored within a permissioned ledger, possibly within Hyperledger Fabric. The public elements are stored within the public blockchain. You can see here that the flow allows a smart contract to be able to control the access to documents. And then using a split of 2 from 3, so that 2 out of 3 verifiers, approvers, will approve if a file is allowed to be accessed. This method here used the Ethereum smart contract method to be able to authenticate online publications. So that might relate to the publication of peer-reviewed work or for a textbook. We can see here that the method allows a publisher to be able to grant permission and then upload a book into IPFS, and then use a smart contract to be able to define who was allowed to gain access to the book. And this outlines the smart contract which supports the publishing of the book. And this research here looked at how we could actually implement the monitoring of a license for accountability and compliance. In this case, we might implement a GDPR smart contract, in that we need to understand the data subject, data requester, supervisory authority, and data provider. And then we would implement that through smart contracts within the blockchain. They extended the work to be able to look at the right to be forgotten, where it is possible to be able to delete a file from the infrastructure if a data subject requests it. And then there is an audit trail to be able to make sure that a data provider has deleted the object or the file from the infrastructure. And the work that we've done is to be able to look to see how we can actually create a sharing infrastructure using privacy-preserving methods around healthcare. A core part of this is to be able to understand the access policy that's required to be able to access a file, a shared file. So let's look at the solution that we're putting in place for this architecture. If we just recap where we were, then we have this wallet which is going to store credentials and so on. If we think of an Ethereum wallet or a Bitcoin wallet, we've only really got a private key, and then there's a public key mapped to that. That's the concept of a cryptocurrency wallet. But in this type of wallet, we can actually have multiple things that are stored inside the wallet that would allow us to be able to access services and store credentials. Then we can have a distributed app ecosystem where it's digital by default. And for this, we can run smart contracts to be able to enact processes on the citizen's behalf. And then we could have an ecosystem which uses IPFS underneath to be able to trace and audit files. So this could be a stack that would build, where we can have the interplanetary file system as the lowest layer to be able to store and to be able to transfer files. Encryption management sits on top of that. And then we have a smart contract factory. Building onto access control, policy management, something that a corporate infrastructure would implement, and then eventually we have the user interface. If we look at some use cases of how we could implement this, then obviously one important element is that we have the public keys of trusted authorities stored in some place, because a digitally signed document must be proven for its signature. In this, say we have an education authority who will sign an academic parchment with their private key. That could then be stored in the user's wallet. When that is passed on to another entity, they will check the public key of the trusted signer to be able to make sure that that is a trusted document. Another way we can actually pass documents through IPFS is to store the encrypted documents within the infrastructure, and then to be able to have a trust authority, such as in a permissioned ledger, to be able to generate the encryption key required. So the citizen could log in to a permissioned infrastructure, prove their identity and their access rights, and then that would allow the creation of the encryption key, which would be allowed to get access to the file. This file can be stored in IPFS because it's encrypted. We can also use a method called cipher policy attribute-based encryption, and this method is being researched at the current time. But basically, there is a policy integrated into the document, and the user must provide the right credentials to be able to generate the encryption key, which will open up the document, the encrypted document. This is still possibly part of a research area, and it's likely that we would move towards this type of approach when storing documents within IPFS. There are other methods that we can use, such as we can provide a pointer to a document that a citizen might have that is stored inside a permissioned ledger. In this way, when someone wants to get access to the document, they then must provide their access credentials to be able to have the rights to be able to view the file. The file itself is stored within a permissioned infrastructure and is encrypted, and only when the user accessing the document can provide the right access policy can we decrypt the document. So there's a number of use cases that we've looked at, including encrypting these CIDs and so on. And these will be implemented inside Glass. But it's when we look at the Citizen Wallet that it becomes even more interesting. And this becomes the focus for the citizen. It contains the single sign-ons for government services, also the key management to be able to prove identities and so on, and store encryption keys that are required to be able to reveal documents. It links into the app ecosystem, where we can have different applications, distributed applications for different types of services. And then it will link into e-government identity systems. Another element of this is key sharding. And with key sharding, we worry that we might lose our encryption keys. And it's possible through things like Shamir secret shares to be able to take an encryption key and split it into a number of shards. And then we can define, such as if we have 3 shards, we can bring 2 back together to be able to create the original key again. Okay, so this has been an overview of towards a decentralized web and e-governance of the future.